When you're looking at the Internet of Things and you have a device like a Nest thermostat, it has a chip in there that needs to communicate with the Internet. Well, Electric Imp came out of Nest and came out of Apple, and we're going to talk about security and what is inside the stuff that's going to be powering your life soon. Who are you?
I'm Hugo Feins. I'm co-founder and the CEO of Electric Imp, which is a company which connects things to the internet.
Yeah. Give me a little bit about your background, because it's quite an interesting background.
So I used to make MP3 players a long time ago. Then I got to get into Apple, working on a secret project, which turned out to be the iPhone. I was hardware manager for the iPhone for the first 4 phones. Then I was architect for another year, working on some other stuff. And then I got involved with Nest. I designed and architected the first Nest thermostat product. Fortunately didn't join.
Fortunately or unfortunately?
It depends which way you look at it. For Electric Imp, fortunately. But really interesting experiences with both those companies. And from that came Electric Imp, which is pretty much the solution to the problem I saw over and over again whilst building connected devices.
Yeah, and you have a few chips here. What are these chips, and what context does this give us about your company?
So these things here are a couple of Electric Imp modules. There's one of these is the larger one, and this is the new smaller one, which is really tiny. It's like sort of 10 by 8 millimeters.
Yeah.
Both of those have Wi-Fi and a processor inside. It's one part of our solution. So to connect something to the internet, obviously you need communications is one part, so Wi-Fi. You also need something to talk to, which in our case is the cloud service. To make this really work well together, we kind of did an Apple-y type take on it, which means that it isn't just a Wi-Fi chip and hey, here's some software to make it talk to our cloud service. It's like really integrated. So this has got an embedded OS, which handles all the security, handles seamless updates and so on. Basically very, very secure. Talks to our cloud service, and it's this tight coupling, which means it's it just works type of thing. So one of the things about connected devices is that, unlike most consumer devices, if you get a connected water heater, hey, it's going to be online for 10 years.
Yeah.
10 years is a very long time in computers and in software updates and that type of context. So if I'm a water heater manufacturer, the people making the connected devices, one of the things that they have to do is think differently about, it's not just a one-off product, it's shipped, and usually you ship it, it's out the door, unless it goes wrong, it never comes back. You need to keep things secure on the long term. So the way we do that is we actually separate the problem down in the hardware, separate it out. So there's actually a virtual machine in each of these things. The virtual machine allows us to separate the OS with all the security parts in it from the application. Yeah.
Let's back up for a second before we go completely
all the way down.
Completely nerdy.
Okay.
You're selling these to. Well, tell me about your business at a high level. Who needs you?
So the people who need us are people who are building connected devices, essentially. So everything from very big companies, like things like the quirky GE Aros air conditioner, the connected air conditioner uses us, down to talking toys, things like Toymail. I don't know if you've seen those, which are really cool little things.
Yeah.
Rachio, connected watering system, Locatron, people like that. They all use us to connect. It allows them to actually build on like a stable connectivity platform and actually concentrate on the application.
Yeah.
And I think that's one of the issues with some of the first generation of connected devices was there was so much work to get them connected that they didn't have the time to put the finesse in on the application. As if you're like Nest, you had the financing, you had the people to do this, but not everyone has that amount of effort to put into the connectivity part of their solution. Yeah. And so this allows companies to play on a level playing field. So
this chip is basically a connectivity chip that gets your device on the internet, basically.
Yeah, it's not just it's like you say it's like a Wi-Fi chip. Wi-Fi chips get you on Wi-Fi. This gets you on the internet. I mean, essentially, every device that has one of these in has its own URL. It has code that can run up in the cloud side, which is great. So we run like Pico VMs for everything in the field, has its own little Pico VM in the cloud, which is kind of cool. So we run tens of thousands of those on per server. It's kind of like it's a pretty dense hosting solution. So we have all that, and there's a VM in the device. And this allows you to like evolve your solution. I mean, one of the things about connected devices, a lot of people keep on having ideas, but it's like they ship something out, it's just like, oh, well, we can make it do this and this and this. And with our platform, you can just really add solutions, change the shape of it.
Even these things, right? These activity trackers, they're sort of connected, right?
Yeah.
But you might want to add a feature to that, or
yeah, and like when you have Bluetooth LE, it's great for wearables. And, we don't really compete in the wearables thing. It's more for independently connected devices,
like cups and vacuum cleaners, and
anything you might want to access when you're away, or that might have a need to talk to the manufacturer. So a vacuum cleaner could reorder vacuum bags automatically, or your fridge could reorder water filters, or all these type of things which are connected sort of supply chain things. And there's a lot of things. There's a lot of value not just to the user but to the manufacturer, because they want to know, like, oh, on this washing machine, on all the dial with the 50 different options, who uses what? And she's like, if everyone just uses this one, 99% of our users just ignore all these other settings. Maybe we should just make a simpler washing machine. Maybe we should expand that out into the different categories, that one wash, and have more options on that, because that's what people use. But right now they don't know. They do survey groups and stuff, but it's not the same as something sitting in someone's home and being used day in, day out.
So why does your washing machine or your cup or your locks need to have a place up on the cloud that also is...
why are the two virtual machines? Why is there the intelligence in the cloud? One of the things is that when you're making a device talk to an internet server, if you want to put all the stuff on the device to deal with parsing JSON and doing all the complex bits to make a RESTful API stuff, that takes a lot more resources. It'll use more power and make the device more expensive. More complexity down in the device is generally a bad thing. So splitting it means you do cloud-side things where the cloud is best at doing them in the cloud, and device-side things in the device. It allows you to like split the problem into two halves. One which isn't resource constrained, one which doesn't use batteries. And that actually works really well. I mean, in other things also, it usually ends up, if people do their own solution, they end up with some ugly glue between the thing and, say, their SAP backend system. And the ugly glue doesn't scale well because, hey, one guy wrote it, and then when they get to like 100,000 in the field, it's like the ugly glue is looking really ugly. With our stuff, we scale the glue for you, and it's a one-to-one relationship. So you don't worry about it. You just make more things. We deal with the server-side scaling, which for a manufacturer, which is generally, they don't have expertise in cloud services, they don't have expertise in security, they know everything about their target market, what they're building, their customers, the hardware, and actually making boxes and shipping them out the door. They know everything about that. It allows them to stay in basically their comfort zone, and allow the connectivity to be delegated to us, and connectivity and the security.
So there's a whole bunch of people building these new connected hardware devices, thanks to Kickstarter, thanks to labs like Highway One that'll help you build it and build it at scale, right? With the supply chain over in China, and the cost of hardware, computing hardware on things is coming down. Right? What does that kind of entrepreneur need to know about this new world and your devices, to integrate this into what do they need to think about before they even get involved with you? I
mean, I think one of the things is a lot of people look at hardware and they just look at connected devices. They look at the connectivity as a hardware problem, partially because chip vendors want them to. So it's like, oh, here's a Wi-Fi chip. There's your Wi-Fi problem solved. That's not the problem solved if you're making a product. So a lot of people are looking at this stuff. They build their design out and they like make one that works. And it's usually quite easy with all the prototyping, the Arduino and so on, Raspberry Pis, to make one of something that works. But then there's a huge leap to production. It's like you can make one. Could you make 100? Yeah, you could buy 100 Raspberry Pis and manually put them together and stuff. Not going to scale so well. But then they're unmaintainable in the field. The thing about what we do is that it's like it's not like a prototyping platform. It's more a commercial platform that you can buy one of for $25. So I think people building hardware, it's always like, it's harder than you think if you've not done it before.
They call it hardware for a reason,
They
right?
call it hardware for a reason. And some of the reasons are, it's like, you iterating on the actual hardware bit is very hard. When you've shipped it, you can't. It's out in the field. It's there.
I learned this at a video capture card company, and we were building a new camera, and the plastic was wrong, and we had to wait another 4 weeks for the new updated plastic to come back from China. Right?
And that's really quick, 4 weeks for a new plastic tool, yeah.
Whatever it was.
But I'm sure that was rushed through, yeah. So, I mean, that's one of the things you have to be really, really... and I've spoken at some sort of startup meetups and talked about hardware, and some of the things, it's like, when you make hardware, you want to do everything you can before you ship the first one to be sure about it. It's like when you build 10 prototypes and one doesn't work, find out why it doesn't work, because it will come and bite you later. Because if you have a 10% failure, make 100. Now there are 10 that don't work. And I really learned this lesson at Apple when, on early iPhones, we were making 100,000 a day, and it's like, oh my God, if you have a 0.1% failure, this is a big thing. There's a big queue of people at the repair station trying to get this thing worked. So you want to find those problems and understand everything about what happens in low battery mode, what happens when it's just out of Wi-Fi signal. Understand all of that at the beginning.
And even Apple got it wrong here and there, right? I mean, I've heard lots of stories, because my friend worked at Apple with you, on the Bluetooth stack, and he told me lots of stories of where they burned up prototypes and didn't understand what caused the thing to burn up.
and we'd run into problems post shipping, which were like just a weird combination. There was one problem which only exhibited itself that we knew of at the 280-85 interchange when you were on a phone call at full power in a certain charging dock, which wasn't designed for phones. It managed to kill the phone, and we spent months looking at that problem and trying to replicate it. But and we fixed it for all the iPhones beyond that point. It was just like we thought we'd made it robust enough. Turns out that if you happen to be driving on the freeway right by Apple, where there were 2 different cell stations and it handed over in a weird way, it's
and that sounds like Steve Jobs' commute. So I bet he was yelling at you.
There were some interesting ones. Like there's a certain senior Apple guy. We'd rate the early iPhones after the first iPhone was before it was launched, but when people were carrying it, it was like. And it'd be like, it still drops my call on my commute down from San Francisco. And it'd be like, after a certain release, it's like, doesn't drop anymore, because he was always on a conference call every time he went through a sort of a dead spot on 280. Yeah. And it was like, well, the reference phone didn't drop it, and this one did. So, I mean, it's very personal. That's why actually, there was always this thing about testing phones and carrying them. And I was one of the guys who was lucky enough to have carry access on early phones, and it's a real responsibility. Everything you find, you have to talk about, because it's going to be multiplied by 100 million or something when they actually get out in the field. Yeah. But testing is critical, and and I advise that for startups. Like, you make a connected plant watering system, get 100 of them out there with friends, get them to whine about every last detail, because you are going to have paying customers whining at you soon. You want to make sure there's nothing to whine about.
So how do you help the entrepreneur
how do we
prepare for this kind of hell?
Well, I mean, one of the things that we do is there's obviously a lot of complexity in connectivity, both in writing your server code and dealing with embedded software. Embedded software is a very specialist art, really, because it's like, well, you have this as 128K of RAM. It's like it's been back in the early Mac days. There's very little resources, and so we deal with a lot of the intricate parts about TLS connection setup and all this stuff like that, and allow them to think about their application. So the way we help entrepreneurs specifically is, you can buy this for $25. You can prototype your solution. Even if you end up, you find that we're not suitable for whatever you want to do, and you have to use another one. But the point is that you can actually use our solution, make something work, and iterate. And that's iteration is the heart of any startup. The fact you get to iterate is the great thing about startup. Yeah. You're not constrained by project schedules necessarily. You want to get something out there, but you have in your mind what it has to be and how good it has to be.
What does this look like on the screen? Because we don't have a demo or anything.
No, I didn't bring it up.
And what does an entrepreneur need to know about the first couple of hours of when he gets his first one.
When he gets his first one to prototype. So we have a really easy way of getting started. We have like a web-based IDE. So basically, you configure this, and the way we configure it is actually using the screen of your phone. So one of the things about Wi-Fi devices is how do you set up the Wi-Fi credentials? So we do it using the screen of a phone. And we have a patent-pending technology called BlinkUp, which uses flashing of the screen to send the SSID and password and stuff to the device. So the first thing you get out of the box, you do this thing with your phone, it's online, and then it appears in your web-based IDE, so you can actually use a Chromebook for serious development. You write your code in there, you can see the debug. I mean, and that's one of the things is you just get started incredibly fast. You can have it, the blinking an LED when connected to the internet, so I can hit a URL and make an LED go on and off, which is kind of one of okay, I have a connected device. That's the aha moment. It's like
it's like the hello world.
It's like hello. It's hello world. Well, blinking LED is a hello world for any microcontroller. It's like yes, it's running code, but this is like it's fully connected securely to the internet, and that's like 15, 20 minutes.
Can it interface with basic XAMPP or Raspberry Pi? Does it have an API for those?
You can, but this actually has. Okay.
So let me talk. Okay. The question was, is there a way to use the stuff from Raspberry Pi or other prototyping environments in here, or do you have to rewrite your code for the Electric Imp?
I mean, you can use it with. I mean, Raspberry Pi is kind of like that's the Linux machine, so it's like that's actually much more connected. The problem is people use Raspberry Pi because it's cheap for doing completely inappropriate things. It's if anyone 10 years ago said, "I'm using a 700 megahertz 32-bit processor to turn a relay on and off," they'd just be like, "This is inappropriate use of technology. It's overkill." But you can use this with Arduino. You've got a SparkFun. You can buy a connection kit which will connect it to an Arduino, so you can run your Arduino code, but then make it speak to the internet. But actually, the resources this has about 40 times more memory than an Arduino does. So if you want to use Arduino, fine as like your processor, but you'll find it's actually easier to use this as the processor because it's 32-bit and has 80K of RAM and all this stuff like that. So you can use it to interface. And I think what people generally say when they say Arduino, it's like, "Oh, can I use these sensors I bought off SparkFun to connect to it?" It's like, yeah, you can. You just plug them straight into this and it works. But you can I can make a connected temperature sensor in 15, 20 minutes, which is like, oh, that's kind of good. And the nice thing about it is because it's not a one-off prototyping platform, if you did it with an Arduino, yeah, you could do it as well, maybe half an hour, maybe 45 minutes, but then it would work with that IP address or that Wi-Fi network. And if you moved it to another house, you'd have to reprogram it and load stuff in. With this, it'll just carry on working wherever, and it's secure, and it's encrypted, and I can update the software on it anywhere. One thing I did, I drove to Las Vegas for CES a couple of years ago now, and almost a couple of years, and I actually left one of these running from 2 AA batteries in a bush about 140 miles outside Las Vegas. I wrapped it in black tape and wrote, "This is not a bomb" on it. But there was
that was really convincing when somebody found it.
Well, the thing is I wanted to put it somewhere, and I found a mall which had open Wi-Fi. There was no landing page, so it's like, oh, this can connect. And it was about 100 yards away, and I just pushed it down in this bush, and I could then, from Las Vegas, log in. It was online, so it didn't actually matter where it was. I could log in, I could reprogram it. I was writing air pressure sensor code on it to check the air pressure and plot graphs of air pressure from this bush in Las Vegas. And it's kind of very liberating. It's a different thing. With Arduino, you're tethered by a USB cable. This is like, where is it? Doesn't matter where it is, it's online. If you're online...
And you can tell whether this is online or not?
Yeah, because it connects up to the cloud service, and then you connect to the cloud service with an app or with the web-based IDE. It's just like it's connected. It's a node on the
How long did it run on a couple of AA batteries?
So it depends. I mean, this one I had it waking and sleeping. It'll run about a year waking every 5 minutes, 3 years waking every 15 minutes, reporting in. And I could alter the code, and the code could crash, and I'd get the crash messages, and I can fix the bug, and without having to run and press a reset button. So wow. It's very liberating. I mean, usually this comes from sort of having made prototypes of things. You stick them on the ceiling, and then it's just like, oh, it's crashed. I'm gonna have to go and get my ladder. Yeah. This is kind of nice.
So I was just in Seattle and talking to an entrepreneur who's putting lights into clothing, and she wants the lights to. If there's 100 people with her clothing on, she wants a pattern to go across the clothing, right? So she would use the Electric Imp maybe to connect them.
She could, but it's like the Electric Imp is more about Wi-Fi, so it's about real nodes on the internet.
Got it.
Generally, stuff on clothing, Bluetooth LE, Bluetooth Smart, what they call it, is really a very good solution for that.
Okay.
Because it's phone centric, so it's person centric. If you have a phone, if it's in your bubble, it's fine. But when you get to things like, I have an AC plug with my heater plugged into it, and it's Bluetooth connecting, it's like, great, I can control it from where I could walk and press it anyway. Wi-Fi means I can control it from the other side of the world.
And the new modern cars have LTE built in, Wi-Fi built in, so all of a sudden you can, as an entrepreneur, build something for a car.
You can have a car bubble. I mean, with the electric, it doesn't need to be connected all the time. So you could have, for example, something which plugged into ODB like Automatic, but every time you came home and it went into it would find your Wi-Fi network and go, oh hey, I'm just going to upload all the data I collected about your last drive, or your maximum speed or your fuel consumption. You think of a bike computer works the same way. You don't need to have it tethered to a phone. And being tethered to a phone works well for some applications, but there's a lot of applications which it doesn't work so well. Industrial, when there's no person, it's not a personal related thing. And also say healthcare, when it's older people, they don't have smartphones, they won't keep the app running, they won't pick the update apps.
No, we interviewed Lively's CEO, and he sets up the network in the factory, so the user never has to touch the network and figure out what the code is and all that fun stuff, right?
So it says a startup using our stuff for elder monitoring, but they do it they have motion sensors and door sensors and so on, which are connected with Electric Imp. So they're actually basically a sort of something as a service, personal safety as a service. And they data mine all the stuff, like all the when you're in the kitchen every day, when you're in the bedroom, how often you go to the toilet during the night, and they look for changes in patterns and flag that as a possible issue. And so that allowed them to do that without actually really making hardware.
Yeah.
They just went to a Taiwanese partner who makes a motion sensor with an imp in it. So they just buy these, but they put their own software on them, put their own intelligence in there, and they separated out the actual making of the hardware from the value of their application. And it's a really cool example of how startups now can start to add, the semantic value is the value that they're adding. It's like the safety of your grandparents.
What are you proudest of in here? What was the hardest thing, or what would you be showing off if you met another engineer? And what would you be like, hey, check this out?
It depends how geeky you want to get. There's a lot of
get geeky on me.
Okay, there's some really, there's the things personally I'm very proud of. It's like we ship revision 1 of the hardware. We're still shipping revision 1. Which is actually pretty good. We've shipped like pretty much 500,000 of these. Same layout, same schematic. We did our homework. Mainly because at a startup, you can get to, before we had funding or anything, I was there just working on it with some of the co-founders, and it's like you have total concentration, and you don't realize how valuable that time is, and it's so great that you get to optimize and do that stuff, which actually in real world you tend to lose a bit. So I'm really proud of it. I'm really proud of the embedded code. I'm actually really proud of the solution. I'm proud of it because when someone gets it, you show it to them, they go like, oh, so that does all that for me. I can just think about my plant watering system or whatever, and it's like, yes, you can. And they're like, oh yeah, that's going to save us so much time. This is so cool. Yeah. So it's really the getting it, but there's many things. It's great.
How did you fund the development of your company?
So initially, I cashed in some of my Apple stock when I left Apple. But since then, in 2012, we got raised Series A from Redpoint. Really great, really supportive, really helping us with this stuff. Really believed in IoT and understood. And a lot of VCs we pitched to went, "Oh, you're a hardware company." And it's like, well, kind of, but not really. It's like we're a service company. But the point is that the way Apple said, to make great software, you have to make great hardware. You have to actually get the integration, and so they understood that the integration was critical to make this thing work. Seamless is kind of the key thing.
Where do we